Hello, and welcome back to this deep dive into Metasploit Payload series. We'll continue from where we left off in the previous part, and in this episode, we'll examine the code that is created and executed dynamically. We will uncover what functions get called, what payload is downloaded, from where, and what happens afterwards. Let's start from the code that gets executed dynamically. We found it previously. It is located at this address here. If you remember from the previous videos, what we see here is the find by hash routine, and in function 3 we have some API calls like get version, which are not that important right now. On to function 4, we've seen already that we start calling other internet and HTTP related functions. For example, this code here loads the WinINet library. So let's follow the code statically and see what happens. After calling load library, we call internet open from WinINet library, which prepares the stage for what we're going to do next. Let's follow this jump. Again, remember, these are just tones of control flow obfuscations. Another jump. This is a lot of junk code here. Then we will follow this function call. Let's rename this function 6 for clarity. We don't know what this is doing. I've already added some comments about the parameters. This hash corresponds to Internet Connect. And if we were to check the MSDN definition for this function, at this point we should be able to see the server name that is being requested. The quickest way to do this is to run the code and do some dynamic analysis. But let's first focus on the static part. The parameter pushed on the stack represents the port, and we can resolve this as well to a human-readable definition. This is Internet Default HTTPS port. So the request will be over the HTTPS protocol, and we need the server name stored in EBX. If we look into the logic of this function, EBX is populated from this pop instruction, which we can trace if we go back to the point where function 6 is called. When we did the call, the address of the next instruction got pushed on the stack. So this code here is actually a server name. Let's see if it makes sense. We'll convert this to data. Okay, you can see things start to make sense. Let's convert this to an ASCII string. We have the server name azsomething.vo and some more stuff. Exactly the name we've seen in FakeNet. Okay, let's go back to function 6. Notice this very interesting trick of passing parameters to functions. It definitely confuses debuggers and static analyzers. Okay, now we have the server name and port. Next, we're calling this function. Let's name it function 7. In function 7, the API being called is openRequestA. If we check MSDN, we should see that the parameter corresponding to ECX contains the requested URL. Again, the same trick, the URL as a string gets populated by this instruction, pop ECX, which will pop the address of this part of the code. Although this looks like code, it is actually data. Let's see. What do we have here? Exactly as before, we have the resource being requested as a string. Okay, so we build the request, we prepare the parameters, then the next function getting called, this internet set option, followed by HTTP send request A, which will actually fire up the request we saw in FakeNet. If the request is successful, there's a jump, G and Z, jump if not 0. If the request fails, the call will terminate the process. So if the request is successful, jump here, let's rename it jump request success, and the other one will be request fail. If the request fails, it will terminate the process, and if the request can be performed, it will create a file. After creating the file, it will read from the URL, let's see, internet read file. Then below another function, which is write file, so we write to a file whatever gets read from that HTTPS URL. Then we close the file using close handle. Then another function here, winexec. This is very important because winexec will actually execute the file that was created. So write file, close handle, and then winexec, which will execute the file and cleanly terminate the current process afterwards. If you want to know more, you can check the MSDN documentation for each of those functions and see their parameters. We mentioned that in function 6 there are two ways to find out the strings representing the server and the URL. Suppose we didn't know the trick used to pass them via the stack. We could have set up breakpoints and see what values get populated before the call. Let's do that now. So start the debugging. Reach the code that is being copied. And here we start seeing those functions. This is internet open. Okay, we have internet open here. Okay, let's see what else. This was the pop instruction that populated the server name, and if we check EBX, and convert this to an ASCII string, exactly as expected, we have the server name. So the server name was populated in EBX. Next, we have the call to HTTP open request, which will have the request in ECX parameter. Obtain from here, and if we check ECX in another window and convert it to an ASCII string using a shortcut, we have the full request as well. Continue a few instructions. Here we have the set option. Then we will actually send the request. Let's make sure we have FakeNet running. OK. We send the request. Let's pass the exception to the application all the time. Pass to the application. And if we want to go back to the function, we can exit the current function. OK. And we have the request here, which created a hidden file and tries to execute it, as we've seen in the previous videos. To recap, in this episode, we've seen an interesting trick to pass parameters to functions via the stack, and we've understood the whole functionality of the shellcode. To remember ourselves, this was a download exec payload with default encoding and obfuscations. It requests a payload via HTTPS, creates a hidden executable file, writes the payload to it, and runs it. And this is just the first stage. Thank you very much for watching, and see you in the next video.